We found when we were applying repeated smoke applications to the same vines that they exhibited evidence of brown necrotic lesions on the leaves. These lesions are akin to oxidant stipple, which is reminiscent of pollution effects, and there's lots of information that can be gained from pollution research in relationship to how smoke may affect grapevines. This led our research to really concentrate on the physiological response of the grapevines to smoke. We could see that something was happening with the grapevines. They were being exposed to smoke. They weren't displaying good growth characters in the following years, and the leaves were being quite affected. Therefore, we conducted some leaf physiology experiments. What we did was we applied smoke to grapevines, and then we went out and measured the photosynthetic response of the grapevines to this smoke. The green is the control and the red is the smoke, and this is the photosynthetic level over a day. What we could find is that the level of photosynthesis decreased immediately in those vines that were exposed to smoke, and this had recovered basically by the following day. We've also conducted this research twice, once prior to veraison and once post-veraison, and we are finding a bit of conjecture in this research in the levels of stomatal conductance. So therefore we're going to go forth probably next week and look at a glasshouse trial on this research, and also look at a model plant such as beans to conduct this research on as well. So the smoke is having some sort of effect on the physiology of the grapevine. This further led our research through to looking at the potential assimilation and translocation of smoke throughout the grapevine. And this year we've also conducted some of the studies in this area where we've exposed the grapevine's organelles to smoke and also to smoke water treatments. So we've had treatments where we've covered up the leaves of the grapevine and we've exposed the bunches to smoke treatments and separate treatments of smoke water. We've also had treatments where we've covered up all of the bunches and exposed the grapevine to smoke, just to see if there's a translocation of smoke compounds throughout the grapevine. We have developed a small-scale system which enables a high throughput of material so that we can put a lot of berries through a smoke application quite simply and quickly. This is just a small tent and our smoke applicator. And we initially conducted some studies looking at the effect of wax on the grapevine, on the grape berries, and their uptake of smoke-like compounds. We had a number of treatments, 2 prior to veraison and 2 post-veraison, where we had treatments of berries that had their wax intact and they had their wax removed. We exposed these berries to smoke for different periods of time, and we found that those berries that had their wax removed had a higher uptake of smoke-like compound guaiacol, and that's both pre-veraison and post-veraison. We're leading our program into developing further outcomes for industry and a pathway of developing tools for industry and resource managers. And in doing so, we're looking at further aspects of our program, in particularly the compounds in smoke and the influence of various fuel types. Will be researched further with Dave's new PhD program. And also looking at the influence of grapevine variety. The purposeful application of smoke has not occurred to various grapevine varieties at the same stages of phenology to depict if there is a difference between smoke uptake for these varieties. There's a bit of anecdotal evidence to suggest that some varieties are more susceptible to smoke than others, but this research hasn't been conducted, so we'll be looking at that area. Also, more importantly, we want to look at the duration and density of smoke application and its effects on smoke development with the final wines. We are really unaware of how much smoke will cause smoke taint. How long is smoke needed to create a smoke taint? And furthermore, look at the period of development that's more susceptible to that. So with using the nephelometer equipment that we're now employing, we'll hopefully be able to gain some leeway in this area and lead to a detection system that can be established in the vineyard to detect when smoke is located in the vineyard and to log that response. And hopefully one day lead to an early warning detection system. We also want to further look at smoke taint specific analysis, which will be backed up by the compound work that Dave is looking at, and furthermore look at the protective treatments. We've applied about 11 protective treatments this year and applied smoke subsequent to the vines. We're just waiting to hear back from the results from that research. There's a number of chemical compounds or chemicals that have been applied to plants alone to reduce the effects of pollution on plants. So we're trialling some of these with grapevines as well. And furthermore, we look to provide decision support, and that'll be the focus of a presentation by Glyn Ward and Drew Haswell this afternoon. So thank you. That concludes my presentation.